Hello, welcome to our Power Symposium event. So the point of this event is to give you the highlights of the Power platform that we all know and love. And I'm delighted today that we've got two of the best industry speakers with us. So David Spurway, Global Principal for Power, and Matt Fordham, who's one of the storage managers in the storage brand. But before I introduce David and Matt, I just wanted to start by talking about cloud. And just to preempt the sign in the room about cloud again. I know we've had this for a long time now. I want to take it from a different perspective today. So we know cloud's been around for 15 years. We went through the realm of cloud first, where the answer was cloud regardless of the question. We've seen in the last 5 years or so that's changed slightly. So we're seeing people thinking, actually, maybe cloud where it's appropriate. Cloud is great, but not great for everything. But I think key really for what we're talking about today on the Power platform is that having cloud and embracing cloud in the right way is existential for the platform that we're on. It's very easy for us to think that we want to keep control of the platform. Oftentimes it runs some of those critical applications in our environment. So the thought of moving it into a cloud, that can be quite scary. But actually I think if we don't, then that's probably more dangerous than if we do. So looking back, historically, you can see the green system here. This is our IBM AIX, our power system. That's always been on premise. It hasn't fit nicely into the public cloud infrastructure. And over time, we've seen this kind of creep of other applications moving into the cloud, whether it's Azure, AWS, IBM Cloud. And so business users have been consuming that either as infrastructure as a service, or as platform as a service, or as database as a service. But all that time, our power systems have been staying on-prem. So what some people have done in the effort to try and move that into a cloud is to push those power systems out to a managed service provider. So in very much an infrastructure view of what cloud is, we don't own the kit, it's someone else's, we're consuming it over the internet, therefore that's cloud. So unfortunately, this model, it doesn't move them too far away from how it was on premise. It tends to be long-term contracts, a fixed capacity. It doesn't give you some of the flexibility that other platforms are seeing in some of the public clouds. So the concept I want to bring to you today is to change the way that we look at cloud. So looking at cloud as a capability, not a destination. So we're moving away from this view of, in order to get to cloud, we need to push the system out to someone else, give the control to somebody else. And to really look at this, I think it's important to understand the key tenets of what cloud is. And these four here are the four. That we can go on. The list can be longer, but I think for the main points behind cloud, these are probably the main ones. So first of all, pay for use. So we want to only pay for what we're using. If we turn it off, we don't have to pay for it anymore. We want to be flexible so that we can scale up and down at a very short notice. We want to be able to provision quickly, and provisioning quickly, maybe we want self-service, but we certainly don't want to be requesting a system and waiting a week like we might do with a service provider or with an on-premise system. So I think when you look at it this way, then you see that moving a system to a service provider actually doesn't give you most of these. And obviously I can't talk for everything, but they tend to be long-term contracts on a static capacity. So this idea of pay for use, pay as you go, that doesn't exist. And I think when you look at this list as well, the most important one will change depending on who you talk to. So like I said before, moving a system into a managed service provider is very much an infrastructure view of cloud. But it's no longer our issue, we've pushed it out to someone else, we're consuming it over the internet. Whereas actually, if you talk to maybe the finance representative of the business, they're probably most interested in the pay as you go. So they don't want to be paying for anything they're not using. But then probably most importantly, if you talk to the business users, the people who are actually going to consume the applications running on this infrastructure, they want the flexible consumption and they want very fast provisioning. Because the whole point of moving to cloud is not just to move the systems out of our data center, it's to give more flexibility back to the business. And that's what the platform as a service, database as a service, and so on platforms outside of Power have been doing so well for many years. So what we need to try and get to is something similar of that on Power. So how do we achieve that? And I think there's two options that we see particularly. So the first one is public cloud. I know before we were showing that was what we were doing for open workloads, not for Power. But actually, in recent times, both IBM Cloud, as you'd expect, but maybe not as you'd expect, Microsoft Azure are also offering IBM Power in their clouds. So all of a sudden, you get the option of not just having to have Power as this kind of this cousin to the other infrastructure that can't move into the public hyperscalers, but now it can. So the main benefits here are firstly co-locating that within other business services that you've got, and secondly it's extending the capability. So it's not just running the same application somewhere else; it's running the same application next to your big data application. So here, for example, we've got Azure Synapse, which is a data platform. IBM Watson, again, an AI platform. So by putting those workloads in an environment where these services can extend what you can do today, it gives you a completely different proposition than you would have just moving it into a service provider or potentially keeping it on-prem. And then obviously we've got platform as a service, database as a service, things that you can extend out to from the Power environment. And because these are hyperscalers, it's what they do. You can do the pay-as-you-go, pay by the minute. It's very flexible consumption, very, very fast provisioning. And that's a model that a traditional co-location provider just can't provide. No, they need to be thinking they're physically buying the infrastructure. They've got to make sure they're covering the cost of that off with those customers over a period of time. But the scale of an Azure or an IBM Cloud means that that's not the case. They've got so many customers coming in that they're able to just provide you pay by the minute. If you only have an hour usage a year, then that's fine. There's no penalty to pay. And then the second one we've got here on the right-hand side is moving into a private cloud environment. So that's, I would like to come on to that a bit more, and I think the best way to do that is going to be to run through a bit of a case study. Okay. So this is an organisation we worked with recently. They are a leading clearing bank. Unfortunately, I can't share the name here, but I can give you all the details around the challenges they had, the current environment, and then how we moved on to build a private cloud for them. So in this instance, they had, like many of you out there, Power 8 hardware. We tend to see most customers will skip a generation, so obviously we have Power 10 out at the moment. There's a lot of Power 8 in the marketplace at the moment. Although the systems have done very well, they've been installed for 6 years, they were at a stage now where we needed to do something, obviously from a support perspective. It's the standard support cycles that need to be refreshed. But probably more importantly here, they wanted to enhance the way that they're providing a service. They're very forward-looking. They realised that as an IT organisation, they needed to be an enabler to the business as opposed to just a provider. So they didn't want to be the ones that were standing in the way when the business said, I wanted to do X. They didn't want IT to say, no, we can't. So this is what we started with. You can see two environments here, one in the UK, one in Asia Pacific, and between them here we've got 39 IBM I licenses, all running IBM I in this case. So what is Power Private Cloud? So imagine this instance where we've got two systems. So in this case, let's assume that this is one system's the UK, one system's Asia Pacific. So traditionally, in all the models, in fact, that we've talked about so far, so in a traditional on-premise environment, in a managed service provider environment, we need to be provisioning for the high watermark of what we think is going to be required over a period of time. So for instance, maybe that's your month end, maybe that's a year end, but we need to make sure that when that most critical of applications run, then we've got enough resource to support it. But what that might mean is, for the majority of the time, actually we're nowhere near that, but we need to provision to the point that would support it. So you can see here our straight lines of how much capacity we've had to provision. The movable lines here basically are what we're actually using. And you can see for the majority of that time we're way below what we provisioned, but we need to go above, as I said, just to make sure in case the worst happens, a big workload runs, we need to be able to support it. So private cloud, basically, this is a busy chart, so I'll talk through it. It consolidates the activations we've got across all the systems in this cloud. So, and then across all the workloads, it takes those as a combined aggregate. So if, for instance, say for example we had we had a pool of 20 cores. As long as all of our systems in the pool weren't using more than 20 cores, then that's fine. So we're no longer looking at it as a system A, system B, system C, system D. We're looking at it as a single pool. And the critical thing here is this is the amount of processor actually used. So if you had a partition that had 10 CPUs, we're only using one of them, only one of them is being used out of that pool. So it's very, very granular. And anything over that, so we come up with a base capacity that we think will cover the majority of our usage. Anything over that time is just billed by the minute. So there's our flexible pay-as-you-go pricing. Okay. So in order to work this out, we can take actual performance data from your system, from a client system. So in this case, this takes usage by the minute. We took it from all of those systems in scope in this case, in this example. So the 2 Power8 systems in the UK, the 2 Power8 systems in Asia Pac. And then we're able to see at any one time what is the maximum used, and then what's our optimum base amount that we're almost never going to go below. So that's what this graph is designed to show. So it's trying to work out where's that inflection point between purchasing. We don't want to purchase everything. We don't want to purchase nothing and do everything pay as you go, because it's probably not economical. So where's that sweet spot? So this is a sizing exercise that we can do on your behalf. And in the case of this client here, we're able to reduce them from the 39 cores on the current system only to 17, which is a reduction of 55%. So from their perspective, the finance team are happy because we're reducing licenses quite considerably. The business is happy because we can provision more quickly. And it also means that as they want to consume more emerging technologies, they're looking at Red Hat OpenShift, for instance, then they can run that using the pay-as-you-go to burst capacity, which is a completely different model than they would have been on previously. Okay. So with that, I would like to bring in our first of our speakers, which is David Spurway, Global Principal for IBM Power. And David's going to bring to you a little bit more about Power10 and also some of the trends he sees coming in the industry. Over to you, David.
Hello there, David Spurway, Global Principal for IBM Power, part of IBM Technology Sales, and thank you to Tom and the Northdoor team for having me here today. I want to take you through what IBM Power does these days, which is IBM Power based on Power10, enables you to respond faster to business demands while sustainably protecting and enhancing your mission-critical workloads. This is how I explain Power to the customers I speak to. It's engineered for agility. It's there to modernize with leading performance per core when hybrid cloud, as Tom was just talking about. And we're also here to be able to respond faster to business demands, as we can now do efficient scaling and pay-for-use consumption across public and private clouds, again, as Tom's been talking to. I'll talk a bit about security later on, but we are here to protect data from core to cloud using memory encryption at the processor level to support security across public and private clouds without impacting your performance. Again, I'll do a bit more about security later on before passing over to Matt to tell you more how IBM Security and IBM Storage can help work together with IBM Power. We streamline our insights and automation with AI as well on IBM Power these days, and always we're looking for methods by which we can minimize any outages, maximize availability, and continue our industry-leading reliability with IBM Power, and at the same time doing this with sustainable compute, which I'll talk to in a second. So IBM Power has continually been improving the performance per core. Performance per core means you can actually do software savings, as an awful lot of software is charged by the processor core. So I was able to do more with less. That means that you can save money. And so this is something we've been progressing through all the different generations of IBM Power, and Power10 is no different. Continuing something that our competition isn't doing is improving performance per core, and that, as I say, saves you money, enables you to do more with less as you move forward. We're also able to do this with certain targeted workloads. I can do double the performance over Intel with many workloads, and also where we get the opportunity to work directly with things like OpenShift and other software applications we can optimize for our platforms, we can do even better than double the performance per core, 3.6 times here. And that means we can again do more with less, enable the applications to do more, and also end up giving you savings. So 3 times better price performance, because we can actually use our hardware and end up having lower software costs, giving you an overall lower cost of ownership for what you're moving forward. That can be done with OpenShift, Oracle, and a variety of other software that's charged by processor core. With Power10, there's a bunch of different things you get in this world. We used to have Power VM as our virtualization we've been working with for over a decade now, and it has that existing on all the Power boxes we've been selling for some time. But the new Power10 boxes come with that Power VM layer in it, come with Power VM Enterprise Edition. It's the version which allows you to be able to have live partition mobility, move things around without having any outage, so you can move forward from older generations into the newer ones without having any downtime. But with Power10, you get a whole lot more than you had before. We have the kind of future worlds of being able to be ready for fully homomorphic encryption and quantum-safe cryptography. Fully homomorphic is where you actually work with the data remaining in an encrypted state, and quantum-safe is being able to work with new algorithms that will be immune and avoid the issues when quantum computers are able to be used by bad actors. Both will be something we can use on Power10 in the very near future. We also, as I mentioned, are able to do AI directly on these Power boxes. We used to have servers that were built for AI that had GPUs built into them, and then we had the servers that actually ran your mission-critical workloads, and these were separate boxes. Now with the Power10 systems, we can actually do AI directly on the servers themselves, using these AI accelerators, using the Matrix Maths Assist on these boxes as we move forward, and allowing you to be able to do the matrix mathematics directly on the data, directly on the servers, in real time, and therefore you'll be able to get your answers when you need them. We can also do throughput that hasn't been possible before using new differential DIMMs, which give you greater reliability and greater bandwidth. And we're also able to use the latest generation of PCIe Gen 5. As adapters come out for that world, we'll be able to put them into Power10 servers without having to change the box. Now be able to give you even more throughput in the near future. This attributes to compute density. We can give you the performance at the processor level and the memory and the I/O to make sure you're a balanced server with extreme compute density. And higher compute density enables you to be able to do more with less on the energy and compute terms. And again, I'll talk more about that later on. Performance, as I mentioned a second ago, is a key thing for Power10 boxes. Doing more with less, lowering your software costs, enabling you to be able to move forward and be able to do everything you weren't able to do before. And active memory mirroring at the top here is a thing which haven't been able to do on the smaller boxes before, but now we can. If you happen to be unlucky enough to lose the section of memory that was running your virtualization, that could be one way you could actually have a server come down in the past. But now you're able to mirror that area of memory, which means even that level of outage is able to be avoided or minimized on these scale-out boxes and across the Power10 range. So we talked about faster to business demands, responding faster to business demands with hybrid cloud. Tom's already spoken about cloud as well, so I'll just briefly mention a couple of points we have that's new in this world. So we're able to use Ansible to be able to automate our systems across the board. Lots of our customers have been running IBM I for many, many years, and now we're able to use the automation of Ansible to be able to move into the kind of DevOps world, be able to have them do the kind of CI/CD pipelines, which you haven't necessarily been able to do in the past, enable them to do Me Too and work in this new agile kind of environment alongside the colleagues of a more thinking cloud and be able to work in that world with that kind of Ansible automation. We can do that with AIX as well. We can do it with Linux and of course Red Hat OpenShift as well. We can do it in the standalone servers, we can do it with the Power Private Cloud, and we can do it with Power Virtual Servers and use the automation to balance across all of them where we need to. So again, in the Power Virtual Server world, the Power10 systems have been announced. We've announced the fact that we will also be bringing them into our clouds, so you'll see that in the fullness of time. It won't be too long now, I'm sure, before we get Power10 boxes turning up in the IBM clouds, so you can use those systems there when you need to. There's also been some new announcements in that space, in that we are now able to do things we couldn't do before. Some of the things which are relatively new is we've been able to resize the sizes of your virtual machines in the IBM cloud by a factor of up to 8. Initially, you could do up to 4 times. Now we can do it a factor of 8. So, for example, if you needed to grow something up into the scale of needing 4 processor cores, you could start off with them just by a half processor core when they're rolling along just by accepting data and don't need the full performance, and grow them up to that factor of 8, up to that 4 processor cores, and be able to do that whenever you like. So you pay for the smaller amount as you roll along, that half processor core, then grow up when you need to, and you don't need to come down. That's not how other clouds work. Other clouds out there, to be able to change the size of your virtual machines, you might be able to add whole new virtual machines, and of course, add cost through that method. You can do that dynamically, but to actually change the size of a server is something that most other clouds you need to reboot. But we can avoid the downtime with Power Virtual Server and do that dynamically. A new thing we've also just announced, which has been around on the on-prem boxes for many years, is this thing called shared processor pools. Shared processor pools means you can take a group of compute resources and be able to minimize the amount of processing power that actually is available to the software. So you're right sizing. You've got the right quantity of processing power and capping it, basically, to say that this expensive piece of software, such as Oracle and others, can use up to this amount of processing power across a range of virtual servers and be able to make sure you control those software costs. The control Oracle can then also give you the performance you need. You can get the performance you're after while controlling the software costs. We haven't been able to do that in the cloud before, but now we can do that on Power Virtual Server and be able to do that for Oracle and other software that's charged with the processor core. And again, this isn't something that's possible in other clouds, such as the AWS's or Azure's of this world. Can also do this while being sustainable. Sustainable compute is something I'm talking to a lot of customers about. They're looking to minimize their carbon footprint to be able to make sure they're going on a journey here that's going to be sustainable and something they can talk to their customers about and make sure they're in the right place. So we're able to deliver more with less. I kind of talked about the performance of processors earlier. We're also able to deliver this performance improvement while using less energy. That again isn't necessarily something our competitors are doing. We can actually deliver more performance with less energy with the Power10 boxes than we've done before, and gradually we've evolved this over the years from where we generated the Power processors back in 1990. So we're actually part as well of the object management group. IBM had the point of view of responsible computing for a couple of years now. We've now taken out of IBM, and you can see a range of names here from a variety of different places. It's not just IBM talking about this now. We're working with Dell, we're working with the people in academia, we're working with other areas that are outside of that world as well, such as the Chartered Institute for IT, and we're now spreading this with desire to do responsible computing across a range of different members to make sure we can actually make this representative and useful and maybe take it to our customers in a consortium sort of way. And what we're able to do with the Power boxes is the scale and performance of the IBM Power Systems based on Power10 means we can end up using less energy than the competition. So the basic idea of being able to get to responsible computing for infrastructure is to be able to use current infrastructure, consolidate and use virtualization to be able to use that effectively, and that drives up the level of utilization you can do on those servers. That works for any architecture, but the scale of the Power boxes being able to get so very, very big and have a lot of processing power in one box, and also be able to do more with less at the same time, means we can end up using less energy than Intel and x86 alternatives, and also less energy than certain clouds out there as well, to be able to lower the actual carbon impact of using this compute power as you move forward. And we can sort of model these things for you if you want to know more. So these are the kinds of numbers you might be able to see if you were to move from a sort of Power 8 into a Power 10 world. The larger enterprise boxes, E1080s, I can put a 4-node E1080 into half the size of that in a Power 10 box, giving you 40% energy saving, and at the same time giving you a little bit more headroom at the same time, also using less physical space. If you're working with older boxes, if you're working with Power 7s, you might be able to see more extreme versions. You might be able to see 79% of energy saving and maybe 10% performance increase with less footprint used as well. It's not just big boxes, smaller boxes can do it too. Power 8 scale-out systems, 40% energy saving. And I've also got one at the end here where I can take 5 of the smaller Power 8s, put them into one of my new world of Power 10s, and be able to give you 68% energy saving. That might be the sort of thing which is more about the business partners like Northdoor can consolidate a lot of their workloads for you onto their own systems and be able to save energy overall. Again, we can model the details for you as you need. And I wanted to pass on to security, because I know that Matt, after me, will be talking about security from the storage world. So from a power point of view, it's an evolving landscape. Security is getting more and more important all the time. It's not just banks that are getting hit by this. You can see from the stats here that actually manufacturing is now actually getting hit even more often than the banks are. And actually I'm finding, even in my own personal life, my children's school got hit by a cyber threat and cyber attack the other day, meaning that they actually lost an awful lot of important information for them. It's on all of our minds, and every business needs to consider when they're going to get hit, not if. Ransomware is extremely common, and it's again the sort of thing which can be the sort of thing that can hit IBM Power. 33% of the increase of a number of incidents is caused by vulnerability exploitations. And that in actual fact is a good thing for IBM Power because we have orders of magnitude fewer vulnerabilities. More about that in a second. 11% server access attacks might not look like a very big number, but it's the second most common attack type after phishing, and therefore the servers do need to be protected. Look to the servers, make sure you're going to protect those, and that can work for existing workloads such as AIX and IBM I, but also it's important to consider Linux. Linux has an increasing 146% year-over-year increase in Linux ransomware innovations across the cloud environments. So when you're choosing to run Linux, you should consider where you're choosing to run it. If you run it on IBM Power, we can lower the threat area, make it more resistant to cyber attacks, and be able to be a good place to run them, maybe alongside AIX and IBM I. So AIX and IBM I are very, very secure. They have got vulnerabilities. That does occur, but you can see that AIX has had 289 over 23 years, so it's roughly 13 a year, and IBM I is in a really good place. It has about 11 over 8 years, maybe just 1 per year. Compared to Linux, you can see that its numbers are more in the region of 1,244 over 20 years, and that's 62 per year. And you can see from the graph there that on the right-hand side, the bars are growing up. They're higher up than they were before as more vulnerabilities are being discovered in Linux moving forward. So AIX and IBMI are not invulnerable. They do need to be patched, you need to consider that, but they are actually in a situation where they have orders of magnitude fewer vulnerabilities than the competition. That can also be said about Windows. So Windows, even the most current version of Windows, Windows 10, 2,889 over 8 years, 361 per year. So Windows has a lot of vulnerabilities that you need to consider. Not all of them will necessarily be available and installed on your systems, but you need to check and to spend the time checking to be able to see if you're exposed to those vulnerabilities. And AIX and IBMI have orders of magnitude fewer, which makes them very, very good at that early stage of resisting cyber attacks. Again, they're not invulnerable. You do need to be able to consider patching them, but they can be good for resistance, and also we can use various techniques such as Power SC to be able to detect if you were to become non-compliant, have a problem in your environment, and be able to react in a kind of zero trust model. You can be good at resist, you can also be good at detect, and then you can pass on to my storage colleagues such as Matt to be able to react after that. Virtualization is also a good place to be able to work to. My daughter here, she was born around about the same time as released in VIO back in 2004. She's 17 now, and you can see her very proudly holding her driving certificate. So over that entire time of where she's been around, VIO has also been around, and over that time we've only had 4 vulnerabilities published for VIO in that entire time. VMware is rather different. VMware has 602 since 1999, and with 51 of them published so far this year, and we still have time for them to find some more. And so that Power boxes are able to be more resistant to cyber attacks because our virtualization lowers the surface area of attack. You don't install virtualization on Power, it's there from day one, there immediately, and therefore it can lower the surface area. Again, not invulnerable, but lower orders of magnitude, fewer numbers of vulnerabilities. And Power 10 takes this and moves it forward. We're able to do new things we weren't able to do before. We have our memory encrypted in all the Power 10 boxes automatically and transparently. All of the performance and benchmarks we do has that encryption running already, so you can see that it has no particular performance impact. And you're also now able to use some of the encryption technologies you might chosen to not use in previous years. Maybe you haven't chosen to encrypt your ASPs with IBMI in the past because it would use processing power. Maybe you haven't used a logical volume manager encryption with AIX because, again, it would use processing power, and that can end up software charges as well. So now we have the crypto engines in every core, and that offloads the effort to be able to do that encryption, so you can choose to use those encryption technologies right up at the server layer, so you don't have any data moving back and forth across the SAN in any unencrypted form, and you don't have to have a performance impact and maybe a software charge because of it. We're also, as I say, ready for the future, ready to be able to install the libraries which are then determined to be quantum safe. We're also able to use fully homomorphic encryption when that becomes available. So ready for the future, as well as being able to do things we can do now. So I've taken you very quickly through some of the things that I think are important about Power 10. Feel free to ask me about other things as you want. Feel free to contact me over email or on LinkedIn. And with that, I'll pass back to my colleagues in Northdoor to be able to take you through the rest of the event. Thank you for having me.
Great. Thanks, David. That was really good. And it's nice to see the topic of sustainability coming up in IT as well. Now, if we can improve things for customers and become more sustainable, then that's got to be good for everybody. And if anybody's interested in moving to Power 10, then we've got some great TCO services, so total cost of ownership, looking at what you've got today, helping you understand whether it's the flexibility that we talked about earlier that I spoke about before, or whether it's just purely from a financial perspective, or maybe you're not sure whether you want to go on-premise again or you want to move into the cloud, then please speak to us and we'd love to help you out. So moving on, the next topic we're going to move on to is cybersecurity. So Matt Fordham, one of the managers for the storage technical team, is going to walk you through how we can maybe architect in some more of those cybersecurity architectures as we move with Power. Okay, over to you, Matt.
Thanks, Tom. So I am going to talk about IBM Storage and how this is going to help our customers prepare for those unexpected challenges that are coming along, and in the masses nowadays with things like the rise of cybersecurity, cyber threat and ransomware. So I want to take you through a methodology, not so much talk about the technology as such, because customers need to think about what are my recovery steps, what are my plans, what happens when this inevitable actually happens, what do I do to respond to that? And it all comes down to a methodology and a framework that IBM has been working really hard on. So we call it Cyber Vault. It's basically a concept around recovery when ransomware gets through, ransomware infects environments. And previously, cyber vaults have been thought of in a number of ways. This is not radically new. This is something that customers have been having to face for years, decades. And it's just about backing up data and placing it in the right place and having the ability to come back should that really be necessary. But vaults have been thought of previously where, yes, we need to put data somewhere where it's immutable, and it was a key focus. So immutability, the fact of putting data somewhere where no one can get to it, no one can change it, it is immutable. It is there until you tell it doesn't need to be there through some kind of retention policy. But it was a key focus, but not necessarily the main priority. Previously, they were really heavily used as an additional data copy. It was another place to put data, a secondary source of data. And the focus was always about putting data in. It was less about getting data out. It was, let's put our data somewhere safe and we're good. So there was less focus on what's the recovery time objective of needing to restore and use that data. And recovery points were not always thought through as well in terms of where they are today. So a much more sort of steady state, let's say, when it came to vaulting data and putting it away for long term. And really, customers had to do assessments to work out what their key services were going to be and how they're going to get those back up and running. And early adopters of a cyber vault strategy over the last few years have proven that it's actually quite difficult when needed to get that data out of the vault and restore it. Because you've got to go through all those steps of restoring and getting things back into production. So they were good, a line of defense, but they were really focused on making sure that the data was somewhere safe. And regulation has always forced these vault concepts to be something that has to be there. And that's not changing. In fact, it's speeding up. So regulation is really coming along to enforce, particularly in financial sectors, where customers have to store data not only for a certain amount of time, but in a certain way. And immutability will be a key part of that. So fast forward to now and cyber vaults from IBM and what they're really all about. Immutability is absolutely paramount. It is the number one, or one of the number one topics on a CIO's agenda. We see it all the time. Customers saying, I need to do immutability. It might be being enforced by regulation, but how do I do it? How do I achieve it? And where do I do that? So it's become an absolute paramount element of what a cyber vault needs to be. And then the real big change is that speed of recovery is actually now key. Not only do we need to store it and know that it's secure, we need to be dependable on recovering from that data, should we need to. And that's driven, of course, by the rise in availability of systems, the fact that customers need to get back up and running quickly should they be hit, and also the effectiveness of ransomware. It comes in and it can be catastrophic. It's devastation through an environment. Traditional methods of DR and having another second location for your data are just ineffective because it's infected as well. So validation is also a real key aspect now of what a cyber vault is about. And that's the concept of basically checking the data that we're storing as we go. So storing and then making sure that it's a valid copy and we haven't stored the problem that is about to explode and take the environment down. And then simplicity, the counterintuitive element perhaps of this whole stack is it's complicated, it can be complex to implement. So simplicity is something that is required and it's difficult to get right. And that's something we've been really focused on with IBM Storage. Lines of business tend to be a lot more free to make decisions about what we do, or what they do, I should say, within the customer when it comes to cyber vault solutions and the services that they're going to adopt. There are many security products that will be in place at many customers, and it's about making sure that they tie in to the cyber vault and the process and the steps that they need to go through to recover. Logical and actual physical air gaps remain. Physical air gaps have been something that we've been doing for, again, decades. So again, it's not new in terms of air gapping data, but logical air gaps are the new thing that makes air gapping more affordable potential for many customers. It makes it easy to adopt because of the technology that creates logical air gaps. And I'll get into that perhaps in a bit more detail. And really what you'll see is that the guidance and the regulation is going to continue to drive this, as I mentioned. And we're getting the feedback now as to why this this list or this approach from IBM in terms of how we're approaching cyber vaults, what customers are looking for, it's being validated by the kind of feedback that we get. We know that some organisations, financial organisations, have stated that if the defences fail and they are a victim of a ransomware attack and they have no control then over their data, they have to be able to restore within a matter of days. Worst case, it has to be a very small number of days. And without that, businesses will fail. And the IBM approach around Cyber Vault and the technology that I'll talk about is about speeding that recovery into not just making sure it's days, but making it in the same day, in the same IT shift, within hours. And that's made possible by the technology that we're putting in place here that's different to previous cyber vaults. So just taking another look at what that road to a cyber resilient storage solution looks like and the ways that we can help. We help customers assess straight away with the current cyber recovery strategy. And we do assessments that are all based on the NIST framework, which is a well-known, well-understood framework for security and technology. Excuse me. And then we basically have the ability to assess and give the customer a actual viewpoint on where they are. What's your risk score? What's your threat level? And help customers really focus on where they should start. Essentially, cyber vaults with the technology that we have now from IBM is about picking out the crown jewels, as we call it. What's the minimum viable business requirements, the minimum set of applications that need to stand up? So services, applications that have to be stood up in the event of a catastrophic failure and basically the business being down. So it's not about putting it in and saying everything comes back up, because it's probably prohibitively expensive. So it's about picking out the right applications, and again, we help with that from an assessment point of view. And then the critical part of technology is that you implement the immutability, the immutable copies that happen for those applications that we've picked out, and they have to happen at source. And that's the big difference with the IBM Cyber Vault with our flash system products. It's about copies at source, snapshots. They are logical air gaps. They are immutable copies that happen at source. This is not backing up to an offsite and then having to go through the more complicated or long-term or long-winded recovery steps. And then we'll integrate that, importantly, into any security events and incident management system, the SIEM dashboard that the customer is likely and I'm sure will be using. There are many security products out in customers. A recent survey actually said that most customers on average have 26 security products, which is quite alarming that there's so much investment that goes into security products to help with those defenses. The important part is that we integrate our cyber vault and recovery processes into those tools, and we can do that. It's all open and driven by APIs, so no problem with that integration. Then we need to think about introducing validation tests, and this is where it gets a little bit more complicated. However, most customers have the tools in place to be able to do this. It's all part of the application stack, so database check tools and in part of the software package or in-house custom scripts that they might need to do just to validate that the data is good. And this is about IBM helping with Northdoor and the customer to basically work out how to validate the data. And then you can really start to think about the next level from there, which is the automation piece. And then you can think about longer term, how we offsite for a longer term data retention. That could be off to a public cloud set of resources. It could be a secondary site. And we'll help the customer really work out what those process steps need to be and how to get the data there in the most effective way. I mentioned automation. It's really the third step in a three-step process. Number one is getting immutability in the first place. Number two is validating that data as you go and making that as simplistic as possible. And then number three, the ultimate phase would be full automation. Software drives the validation as the data is stored in these immutable copies. So you have confidence in what happens. So the key attributes really in summary, immutability, absolutely key and paramount, and it's something that you need to think about getting at the primary storage level. Proactive monitoring, nothing really brand new here. That's something that has to happen for customers in terms of security defenses. We can look at infrastructure components and we can spot anomalies, and we can help with technology that comes as part of CyberVault to help complement what a customer already has and to help enhance what they have around that monitoring. You're looking for triggers, warning signs. If systems are busy, there's a good chance they could be encrypting storage or encrypting data, and you want to intervene as quickly as possible. If somebody's been, if somebody no longer works for the company and they're trying to log in with their ID, it's a warning sign. You need to catch it and basically have that integrated into the whole environment. Testing and validation of data copies through probably existing tools, maybe some custom scripts, and then the reliable recovery steps. Okay, so I've done all of this, I've checked, I know my valid copies, I've got one to recover to, and just what are those recovery steps? And all of this can be mapped out as part of our framework, working with Northdoor for the client to understand in a much more easy to consume way than trying to go it all alone. Automation is that absolute cherry, let's call it, on the cake, and it's something that we can do. Northdoor bring a lot of skills here around Red Hat Ansible, and it's one way of really achieving automation when it comes to these environments. So we can plug into the existing environments, we can introduce new technologies such as Ansible and automation, and all of our storage and our CyberVault can be driven through the available integration APIs. Just to dive a little bit deeper, not to get too much into it, but just to really highlight what the immutability is really about in terms of how we do it on a storage device. So flash systems are the range of storage technology. Safeguarded copy is the actual name for the immutable snapshot. And the way it works is from a volume that's primary production volume, we take snapshots. And we take those snapshots and we put them into a safeguarded backup location. And that is ring-fenced by extremely tight security so that not even a super user or a elevated privilege or an admin of the system, they can't change that data and they can't delete it. The point is separation of duties so that we set the policy as part of the setup. You take the copies and the copies will live there as part of that policy. And it's about reliable restore points that happen. And because they're off the primary storage, they are instantaneously available. And that means that you can access that data through a additional step, additional copy, if you like, called a recovery volume. So the recovery volume is where you then go and do your forensics, your validation, and it's the point that you will use to restore back to production. So it's very effective, it's very simple to implement, and in fact, a lot of our IBM Flash System customers can make use of safeguarded copy through a simple software update of their systems that are in place today. But it's incredibly efficient in terms of how we have implemented this into primary storage. And it really changes the game when it comes to creating a CyberVault. Because previously you'd have to go to backup and do all of the steps on a backup copy, which means you've got to go through all of the restore steps when it comes to backup. These being snapshots, it's instantaneously recoverable once you know it's good. So we'll just quickly go through, I guess, a little bit more on the monitoring side, the fact that we can do events management, events monitoring through security products. IBM security products are really strong here with QRadar, XDR, and you can have a whole suite of trigger points. Customers may have many security tools, as I talked about previously, but whatever that is, it's about spotting the alerts, the events, having the alerts go off, and then turning that into action. The action when it comes to storage is basically make the application safe, make sure that we've got a safe point and trigger a snapshot. Because the quicker we take the snapshot close to an event happening, the shorter the RPO in terms of being able to restore to that point if we know it was a malicious event. So it's integration through those tools, integration into any existing tools, and again, this can all be worked out through our assessment and through our workshops that we're happy to do with our customers. The components of the management of those copies it can be done in multiple ways, and one that's probably most relevant to many of Northdoor's customers is Copy Services Manager, because this integrates into an IBM i environment, which I'm sure many customers will be interested in understanding, and maybe even using today if they're already using external storage with IBM i. But the key thing is that we have all of these toolkits and capabilities to plug in and manage the schedules, manage the snapshots, so that customers don't really have to think about this. It's set up and think about it a lot less, and then it will run there with your policies and your schedules. So we're going to go through the process flow, really work out where the source volume is and where you want that safeguarded copy to exist. It could be right next to the source on that same production box. It could be another copy somewhere else. Now, with the software, and that's the storage system in the flash system, it's running some software that allows you to put a virtual instance of that storage environment in public cloud resources. So we can actually build these in Azure, for example. And that means that you could think about having your cyber recovery process and clean room, and effectively where you do your validation. It could be completely off your premises in another location. So either a DR site or a public cloud resources. Once you're there, or you know where you're going to run your safeguarded copies, of course, we implement the safeguarded copy functionality. So we have that flexibility from a storage level to help you think about where that needs to be, either all in the same place or somewhere else. And we'll create those immutable copies, and we'll build the catalogue. And typically you'll see this as maybe a few days, maybe a few times a day. On average, across our customer set, it's a few days, it's a few copies and a few days retention. The clean room concept then can exist wherever those copies are. And this is the concept of, as I talked about, recovery volumes, map them to a partition, to another host, and run those forensic tools that you need it to be, that you need to have running. Work out where the good copies are, and then report that. This is where it gets important in terms of the integration. Report that good copy back into your security and events management system, so that you know you can restore to 9 o'clock this morning because the copy has been validated and it's checked. We are good for a restore point in the same day, in the same IT shift. And then, if there was an attack, then you know instantly you can go back to that 9 o'clock copy. You know you can restore quickly. And if you are at that point where you know you can restore copy and comfortable with the impact that will have, then pushing the button, the restore is literally seconds, minutes, because it's using snapshot technology, not restoring from a backup. And we're good to go to get that back into production. So it all sounds simple. It is something that we can really map out well. We make it tailored to a customer's environment. We use their own technology. And if we want to think about going to that third level, this is where we'll start to think about the full automation layer that can come in, such as Red Hat Ansible. And we're doing this with many clients at the moment, where we're starting to really get to that point where it's an automated clean room validation and restore points. And it absolutely integrates with IBM i through Copy Services Manager, as I talked about. And that concept there from that previous picture is simply mapped out onto partitions. So using partition technology, the partition managers, you can have the concept of, from production, we'll have a management partition that will use Copy Services Manager to integrate into that IBM i environment and create the safeguarded copies. And all scriptable through the right tools, through the right validation steps, so that you can mount it to a recovery partition, you can do validation, and then you can think about putting that back into production. And I guess just to re-emphasize the fact that this runs on technology, our storage systems. The storage systems are running Spectrum Virtualize. Spectrum Virtualize is the software layer, it's the operating system of those storage boxes. That can exist in public cloud resources. It gives customers huge flexibility to think about where they place this Cyber Vault solution, how we use it, where it needs to be, and it gives that full flexibility to literally think about going anywhere. And we can even layer this on top of existing storage devices because it supports virtualization of storage. So you could potentially reutilize some of that previously purchased non-IBM storage that might be sitting around for the purpose of Cyber Vault. And this is something that we definitely encourage customers to explore. And I've included a quick visual diagram of how this would look in a hybrid environment. It's an on-prem using production, still maintaining a production and DR scenario on the left-hand side. That's storage that's doing general replication and a DR solution. But of course, ransomware comes in and it can take down production and DR in a heartbeat because it's a synchronous copy. So it's thinking about where you place that data for your Cyber Vault, and Spectrum Virtualize can help you place that in multiple locations, including, for example, Microsoft Azure. Cyber Vault has been one of the hottest topics for our customers. We've had so much engagement with our customers around how can they switch on safeguarded copy with their existing IBM storage devices, how can they implement it and put it into their own environments. One particular example that I've just included here with a major consultancy firm, and the most critical thing was that they had an SAP workload back up and running within minutes and hours, and they pushed us to actually really engage to make sure that this was a valid way of achieving that should they have some kind of catastrophic effect or obviously a ransomware attack. But really absolutely able to deliver that solution through Flash System. It was very simple to get up and running, to implement Flash System as part of an SAP supported SAP HANA stack and workload. And once the Flash System was in place, it's then just switching on safeguarded copy. They've been able to build everything around that process now, test it so that they know that they can recover within minutes, and it's exactly the results they were after. They could not do this with backup. They tried, they looked at many options, and they could not achieve the results that they were looking for without IBM Flash System and safeguarded copy. I'm going to close out, I guess, this section with just a quick summary of where IBM Storage is in terms of solutions. Cybersecurity is absolutely paramount in terms of the solutions and offerings that we're delivering. And we'd be happy to explore that further with any of your customers. Sustainability is extremely important for us. And the technology like storage virtualization that I mentioned quickly there, really help customers to think about better using, upcycling the existing storage that they have so that we can do cyber security on existing storage that might not otherwise already support that. And that's a really strong area for us to explore right now, of course, given the circumstances of the world. We also are pushing forward heavily with modernizing applications, and this becomes quite relevant to IBM I customers where you're starting to think about more infrastructure as code, more automation around the partitioning and the integration to further applications and services. And we've got a huge effort and energy behind creating the right platform using Red Hat OpenShift where possible for that kind of modernization of applications. And data protection anywhere is of course extremely important as well. So cyber vaults and the benefits that they bring of rapid recovery do not replace long-term data protection and maintaining, regulation support for maintaining documents and files for the many numbers of years that customers need to do. So we still have to think about long-term data protection in conjunction with everything we're doing around cyber. I think the important thing to point out again, as I mentioned, we can really help you get started with an assessment. So really talk to us, think about the concepts that you need to achieve, but engage us, use the services, use the assessments, and we'll really help you get that conversation started and work out what logical steps you need to think about next. And that is really, hopefully, something of interest to you, and where I'll pause and I'll hand back to you, Tom.
Thanks, Matt. It's great to see, without making many changes on the Power Platform, how we can add so much more resilience to it just by making these changes on the storage architecture side, and also building in this proactive checking model so that we're making sure that if the worst does happen, we know which copy we can go back to bring the business up quickly. So if anybody's interested in learning more about this, we can provide a cyber resiliency assessment. This is not just looking at the systems, but also looking at the procedures and processes that you have in place today, and then providing you with a scorecard so you understand where you're maybe strongest, where there might be opportunity to work, and where that work on investment could be best placed. So again, please contact us if we can help with that. So with that, that ends our event today. We're really, really pleased for you to join us, and thank you for your time, and we hope to speak to you again soon.